This presentation is with regards to assignment 5. We are going to make examples, and we are number 8. That's for the course Math 1 to 2, and the topic is geometric distribution. So this question says that a game at a school fair consists of choosing a matchbox from a display of 120 sealed matchboxes, of which 10 contain a dollar coin. You cannot continue to play after choosing a winning box. So the first question asking, what is the probability of choosing a winning box on your first attempt? Part B is asking, how many attempts would you expect to take to choose a winning box? Part C is asking, how many attempts would you need to make to be 75% certain of winning? And part D is asking, if it cost 20 pence for each attempt in part C, how much would you have won or lost? So our example for this question is as follows. So the example says a game at a school fair consists of choosing a matchbox from a display of 100 sealed matchboxes, of which 15 contain 2 pounds. Okay, you cannot continue to play after choosing a winning box. So let us look at the first question, part A. So part A is asking, what is the probability of choosing a winning box on your first attempt? So that's basically finding the probability of success, okay? The probability that X is equal to 1, that the number of trials required to win. Is 1, probability of winning on your first attempt. So that's P, and that will be 15 out of 100 because you've got 15 matchboxes that contains the 2 pounds out of 100, which simplifies to 3 over 20. Part B is asking, how many attempts would you expect to take to choose a winning box? Okay, so expect is another way of saying the average. And from unit 5, we have already proven that the expected value for geometric distribution is 1 over P, 1 over the probability of success. Now, the probability of success is 3 over 20. 1 over 3 over 20 is 20 over 3, and that gives us 6.667. And that's the average, that's the expected number of trials to succeed in winning. Now, Patsy is asking, how many attempts would you need to make to be 85% certain of winning? So the solution here is we have to interpret what this means. To be 85% certain of winning, certainty of winning is interpreted as winning within a certain number of trials, and this is denoted as P of X less than or equal to R. Okay? And this has to be 85%. Now, to calculate that P of X less than or equal to R, we have already identified it is 1 minus Q to the R, okay, in the unit 5. Here it is. Right. Now, basically, further analysis will reveal that we would like the number of trials to be such that the probability calculated should not be less than that certainty. It should be greater than that level of certainty. Okay, let's repeat that. The number of trials, which is R, here it is, so should be such that when the calculation is made, when the 1 minus Q to the R is performed, the value should not be less than 85%. It has to be greater than 85%. So that is the rationale for this inequality. And Q being 17 over 20. And we can simply solve for R. Now, a little bit of algebra, we go to cancel out negative 17 over 20 to the R from the right side. It becomes positive 17 over 20 on the left side. And we go to cancel out 0.85 from the left side. It becomes negative 0.85 on the right side. This calculation gives us 0.15 on the right side. Now we go to apply logarithms. Here we choose to use logarithms to the base of 10 on both sides. And the purpose for this is to apply this property of logarithms because R now is an exponent. So this property of logarithms allows us now to rewrite this left side with R multiplying to log of 17 over 20. And this permits us now to divide by log of 17 over 20. Log of 17 over 20 is actually an exponent. It is a negative exponent because the base is 10. So to get 17 over 20, which is a decimal, 10 needs to have a negative exponent, 1 over 10 to whatever value, so that you get a 0 point something. So log of 17 over 20 is a negative number. Now, when you divide it by a negative number, the inequality sign changes direction. And here you have R has to be greater than log of 0.15 divided by log of 17 over 20. And the calculation gives us R has to be greater than 11.67. R is equal to 12. That is the number, that's the least number of attempts required so that this calculation should give you a certainty of 85%. 12 times. Now, part D is asking, if it cost 10 pence for each attempt in part C, how much would you have won or lost? So, won or lost, we are talking about profit, okay, negative or positive profit, positive or negative profit. Now, we are using capital Pi for profit because capital P is already used for probabilities. And pi now is the symbol that the Greek used to denote the sum, the P. The person we're using P while they are using pi. So we can use capital Pi for profit and R for revenue and C for cost. Normally, when you translate a word to a letter or symbol, you use the first letter of the word. So profit is equal to revenue minus cost. So let's calculate. The revenue would be £2. If you win, you are going to get £2. And your cost now will be the amount that you pay times the number of trials. So we're talking about trying 12 times. Each time you try, you are going to pay 10 pence, that's 0.1. So that's your cost will be 12 times 0.1. So 2 minus 12 times 0.1, that's 2 minus 1.2. And 2 minus 1.2, that will give us 0.8 pounds. Okay, 0.8 pounds is like 0.8 cents. To change that to pence, that will be 0.0020. And that's practically this is not so feasible. But on paper, you can talk about 0.8 pounds or 0.8 cents. In any case, you would have won 0.8 pounds if you try 12 times.